Okay, hi everyone. We are meeting to talk about the compiler here, and Christopher is in charge. And where do we start?
Well, I think this is where we left off. So I mean, there's basically there's the stuff that we skimmed over last time, and then there's actually like two more additional things. But I'm pretty sure this is where we started skimming. So right. So basically, what this is, what the interface function stuff is basically it's basically for having certain callbacks for things like when the reference count turns to 0 and stuff like that, kind of low level things where we don't want to have an actual function, that because you'd never want to call it yourself, but you'd still like to provide like run this code when this happens.
So hold on a second. So this is who is going to be running code? Who is taking the callback? Is it an external C program or what is it?
Well, it depends on what it is, but I mean, I'd say that most of the time fundamentally it's the compiler itself is going to be running these. Yeah.
Our code.
So can you give me an example of what?
Well, the on-free thing is an example. So.
Right. So this, I mean, well, there's sort of some different ones here. So on free is one where, I mean, this would be like when the reference count turns to 0, if you have some big data structure, maybe one that's from some library, and you need to call some library function to free it. That's where you do that. But that's a kind of a library example. There's some that involve no libraries. So for example, these two from expression things, which maybe could have different names. These are basically like, so if you use compile expression declaration, it automatically knows how to convert between data, its data structures and expressions. But if you just use a type declaration, you define a struct or something, it has no idea how to convert that to and from an expression. So you need to give it basic functions where you tell it, this is the function for converting this data structure to an expression. Here's the one for the other direction, and so on. But, the other option would be to have a function that's like, the from expression function, and it's like a symbol from expression, and you call and you just add a declaration to that symbol, and then it will know what to do. The problem is you never want to call it yourself, right?
When you declare the struct, okay, are you in a position to give the from and to expression things upon declaration of the struct?
That's what the compiled expression declaration did.
Well, kind of. I mean, so the answer fundamentally is not really about providing the functions there. I mean, so in compiled expression declaration, you don't provide the function. It figures out what the function should be because it's sort of a restricted case. I think that you couldn't just provide the function though, because these can be sort of polymorphic and complicated ways where you do something like, oh, here's the unboxing function for packed arrays of integers, and here's the unboxing function for packed arrays of reals, and et cetera, et cetera. So it can be more complicated than that.
Right. Okay. So, okay, but what am I thinking here? So wait a second. So what happens if you set up a struct and you don't give the from expression, and then the from expression is needed?
It will fail. It just won't compile.
Oh, I see. It knows at compile time.
Yeah,
it'll compile so long as you keep it inside the compiler. What it won't do is it won't come from the evaluator into the compiler or go out of the compiler back to the evaluator. So
right, like you couldn't return this struct from a function without telling it how to convert
code function. You could return it from a function to another compiled function. You just couldn't return it to the evaluator.
Right.
And converting these things into and out of the evaluator is super powerful because it lets you interoperate with, sort of evaluator code. I mean, it's incredibly powerful.
Okay, so hold on a second. But that means that, okay, so what does it look like? So you declare a struct. How do you declare the struct?
So that would be with type declaration, which I don't think I have an example. Actually, I might have an example up here. Although we changed these to be associations, but yeah. something like this.
Okay.
I'll
So
copy it
why
down.
is it that you don't give these interface functions along with the actual type declaration?
Okay, so take this case. Take this case. Suppose it's Suppose it's polymorphic. It can take a field. This can be any type or something like that. And now I have two different conversion functions. One for the case where this t is an integer, and one for this case where the t is a real 60, something else, whatever, right? That's really easy to do like this, because it's sort of like, well, I'm just going to compile like
one
version of this.
Write a couple of types for it, Christopher.
Yeah, I mean, you could do something like, typed of. Well, I could just say something like, foo of integer 64 or something like that.
Did we settle on the new syntax instead of that foo? We had that nice syntax with colon
double
bracket.
colon.
Yeah, we did. Yeah.
Okay.
Right. So I mean, you'd have something like this, and that would handle the integer case. And then if I had a different real case, you can do that.
Wait a second. What the hell does this do? I don't understand. Oh, don't you have to give it code?
Yes,
you do have to give it code.
Which
How does that? Wait a minute. What the heck does that mean? Why is the type?
This is the headdress, or not headdress. This is the sort of operator form of typed.
Hold on. What does that mean? So you can say typed of a function, and that's equivalent to putting function of like a typed lambda, function of typed of x. Is that correct?
Yeah, except it's giving the output type.
Right. So
useful. Yeah.
Right. So first of all, these are the same thing.
I didn't know that before. That's nice. That's cool.
Yeah. Which lets you put the type at the beginning, which is kind of nicer than having it at the end and so on. But
you bring the type on the function. You see, that's
no, it's nice because it also allows you to take a function that was just a naked evaluator level function and typify it.
Yep. Absolutely.
How do you do multi-argument? It's just a list.
Yeah, it's a list.
Right? Yeah.
But how does that work? Oh, it's just a list there inside the typed declaration.
Right.
So
and
how does it work?
This is how you write the type of a function: is you have a list of the argument types, and then you have the return type.
Right. So this
okay. So can you just show
argument.
me inside a function how that works? Because a function usually would have multiple. It would say function of list x blah blah
make
blah.
Another function declaration. Yeah. Right.
Yeah. I mean, you'd say let me do this with a different.
Something different.
You'd say
so I'd say
typed.
foo. And it's going to say, right, okay, so there's two ways of doing it. You can either do function of, typed.
Of arg1, okay. Or can you do a function of typed arg1, arg2?
You mean have the arg1 and the arg2 inside of the typed?
Yes, because that would be the analog of that operator form.
Well, it's not quite, because
these
I
are the
disagree.
arguments.
Because so the arguments. So the point is that this is the type of this whole function, right? So that makes sense to have that. This is the type of this argument. It makes sense to have that.
Exactly.
If I give a list of arguments here,
yeah, I get it.
It doesn't. In this case, it infers the return type.
Yeah.
If it can.
Right.
But if you wanted to give the return type inside the function, couldn't you do that by having a syntax that's of the form function?
We don't have a syntax for that.
Well, I understand it, but I'm suggesting a syntax.
Right. So the way you do that right now would be you'd sort of make it very easy for it to do the inference by basically just writing something like like this, right?
So the return value is wrapped in a typed.
Yeah. Right. And then it's like and then it can obviously you're forcing it to figure out what it is. I mean, we could maybe have a syntax like this or something.
Well,
that's a little exotic.
Why not just have the syntax where you can take the operator form and stick it inside as the first argument? In other words, function of.
Because it doesn't have the type name.
It doesn't have the argument name. The parameters, right?
No, but why not? Why not just do this? Why not just take the thing that is right now in the operator form of typed, and just make another one, make another one, make another.
It's awkward, Stephen, because of evaluation. Remember, function is hold all.
Yeah.
Wait, you're going to say something like this?
No, get rid of the typed inside. Just the type specification. Whatever the
this
type
one.
specification was there, yes.
Where
What
are
is
the
the-
arguments?
Where are the arguments?
Hold on. I see. So that's the signature. I see. Well, maybe there needs to be a form like the argument names arrow and then that typed thing or
Right.
something.
That's kind of what I was saying. I mean, you could have some exotic thing like this.
Yeah, you've
But-
got that written down there. We could have something like
Yeah.
that. It seems a bit weird that.
Well, it's also all right, I think, to wrap the. If you could you also wrap the whole function outside and typed, rather than the operator form? You could
Yes,
just.
that's the same thing. Yes, I mean these are equivalent. So yes, you can just say typed of, this comma this.
Yeah,
that works too.
Okay, and by the way, the foo in this case, that is simply the struct name, right? So the foo has nothing to do
Correct.
with the function.
Yeah. That is
correct.
nothing to do
That's the
with
type of the first argument.
Okay, and so am I right in believing that in the case where you have typed arguments, they always have to be named as well? There's no hash, there's no nameless. It doesn't make any sense.
I don't think it makes any sense.
Hold on, let me just see. So, sorry, in the headdress wrapper, not headdress, in the operator form, you're not naming, you're simply giving a type signature. So in that case, you could in fact have anonymous named
You could.
arguments.
You could.
That's very nice that you can just give the type signature and apply it to the function. Okay.
Because it's slightly outside of the function, you see, it's like metadata or something that we're.
Well,
attaching.
yes. But so how does that apply to down value assignments and things? Is there an analogous thing you can do there? How do you imagine
No.
specifying the types for down
Yeah,
value assignments?
right. So what I've implemented, which is not a final thing for the down values, is you make a function declaration. You just say this function, go and use the down. Here's the type and use the down values for it. So it's not really, a polished thing. So we don't have a way of attaching types to down values.
Okay, but hold on. Let's think about this for a second. So you've got some function f, and I mean, long ago, I mean, it's still used in the system. The whole mechanism of the way install works and the way that it creates a compiled code call, whatever it's called. What is it called? I thought something external call or something that is a piece of the down value list when you've done an install. Is that correct?
No, that's long since. There's no trace of that in the evaluator. There's only down code. The only, internal code you can call is down code.
No, I'm saying if you use install, right, it installs a piece.
It goes through down values. It installs some down values that get called.
Yes, I know that, but
Right.
I know that. But okay, sets up definitions that send call packet objects to the external program.
It does that with down values.
Yes, I know that, but I'm saying it adds a down value, which I think is what should be being done with the compiler as well. That it adds a compiled down value, or you have a mechanism. No,
Well, I just
you're
attach down code. I mean, I just add down code to the symbol.
Right. I mean, there's no syntax for this right now, though. Right. I mean, so there's
an internal.
there's
There's an internal syntax for it, but
right.
Okay, but
there's
one
no
problem.
Yeah.
The down code is run after down
Yes.
values.
yes.
And so if you've got super efficient down code for one case and you want to fall through to down values, how do you do it?
Well, if it's just one case, I mean, if it's all the, so I have a thing that compiles all of the down values.
I know, but let's
It's
say you can't
massively
do that.
faster. Right.
Yes, I know. But so,
Yes,
so
yes.
are you saying that in the case, okay, so you've got a bunch of down values, you try and do a compilation, certain cases which you specify with types are compilable, other cases are not, so they need to fall through to the down value code. How is that supposed to work?
Well, then you would probably have to have the, it would depend whether they're overlapping or not. I mean, if they were all sort of overlapping, you'd have to leave the down values and just.
I know that, but I'm
Well, no,
asking,
it's just
how
the
do you
case.
do
The case
that?
is something like you have mean, and mean has its own. Well, mean is made. Pretend mean is implemented in the top level. a mean has its own definitions, but when you apply a mean to a bunch of around objects, you'd like it to use this compiled code function, right?
Yes,
that's basically
the
the use case, right? But of course, mean works on anything, right? And so it's not like there's going to be a hole in the patterns. So I mean, one option would be to change the down values so that there's just a hole in the patterns where it checks that, oh, by the way, your argument isn't just a list of a bunch of nice arounds. But of course, that's a little bit painful. Another alternative, which is maybe also not great, would be that you just add a down value to mean that's sort of like, when mean is applied to a list of, arounds, then call, internal mean. And internal mean is this down value compiled thing, although that kind of sort of gets rid of half the point of having down code.
Okay, let's look. Okay, right now with install, what it is doing is that mechanism. That is, it is installing down values which point to external code.
Right. So what does install do if you basically try and overwrite existing function?
It'll stick its down value in front.
It depends whether the existing function has down values or not. Actually,
no. But it's going to stick its thing in front of the existing function. It's going to stick
front
its
of
thing
or behind.
I believe it's in front, but I'm not sure. But I mean, it's not satisfying. It doesn't do what Tom's code is doing, which is to have a super efficient down code call. Right. So it's still going through the evaluator. So the question really is, what we need is a sandwich of some kind, where if you say, here is a type declaration, and this is the case where I can call newly installed down code. What I really want is a sandwich where there's user down code, user down values, system down code. Isn't that correct? In other words, we need a new hook that can take user down code and put it in front of user down values. Am I correct?
Right. So the idea is that basically that it'll always try and use the down code for running, the optimized version of mean that works on arounds. And only if that fails, then it will go to the down values.
That's right. Because right now we are.
Well, that would be. Hang on. Can I show you what I've done? Because I think we're a little bit in the dark. Okay, here.
Okay, fine.
So,
go ahead if you want.
Right. And if we just want it to be that would be very easy, because we just have a fall through case that goes back to the down values, you see. I need to.
Would you like to share?
Yeah, someone needs to stop. I can't share. Right. Right, fine. So this is right. So here are some down values, and this is what I implemented. So it's not. So this you would do function declaration. You give it a type, and you say use the down values, and then I can compile it, and then I can get.
Hold on. Let me just understand the syntax even vaguely. Okay,
so
this is a function.
This is compiling it in place.
Yes,
sort of.
Attaching down values, and you can see. Hang on, somewhere I've got away. Right.
And there's no mixture of down values and down code.
Right, which is not going to cut it. It's not going to cut it. That's
well,
not
hold on. But it's a good start to this. So this is basically from these down values, it generates this function here, which it can compile. And not only that, it's not going to fail compiling this, because now these could in fact also be calls to the evaluator as well. So they
okay, fine. So your idea here is
not only that, this is going to inline everything, will be massive.
No, I understand, but I'm trying to understand what you're doing. So what you've got is a preprocessor that goes from
down values to a function, and then it compiles that function.
Right. So hold on.
And presumably there could be some sort of fall through of if it can't compile that usage, then it's just going to call the evaluator.
At the moment, right, there has to be a fall through, a catch-all. It can't.
Okay, let me just understand this for a second.
In
What
fact,
you're doing is
This
wait
is made
a second.
one function.
Okay,
This is inlined everything into one
Tom,
function.
it's lovely, but I'm trying to
It's like,
understand the.
a few instructions will, this is a nanosecond processor. So, right.
Okay.
And this is going to run
Unraveling
orders
for a
of
second.
magnitude
Hold
faster
on,
than
hold
running
on,
this. Right.
hold on,
Yep,
hold on. What you've got here is a more generally useful function, because what you're doing is
Absolutely. Yeah.
what you're saying is you've got down values. You're turning the down values into a lambda, basically.
Correct. Exactly.
Okay, so that's a general thing of some utility.
That's a lambda that represents the sequence of patterns. And
Okay,
it can't
hold
do all
on.
patterns.
It's not, you're right, it's not all patterns. So one of the issues is you're going to do that, and it's going to eat some patterns, and some patterns, what's it going to do with it? Until we have pattern compilation, right? So let's imagine that we had a function. Let's imagine that your definition was f of g of x blank colon equals whatever, right?
F
of g of x blank.
X
G of x, no, g of x blank, g of x blank, g of x blank.
Like
inside
that.
there, right?
Yes,
like that, right?
Yep,
Okay.
yep.
Your pattern, your compiler will only take naked variables there.
Well, hold on. No, not quite, because my compiler is taking
type objects.
I'm giving a type to it. Now, if I wanted to compile this, I could say something like, expression. No, that's
right,
what
it won't
do.
be able to access the X is the point.
No,
or like it won't be able to automatically.
Not. I haven't implemented it, but it could access the X, because if it knows that this is expression, it would know how to bind this against X. And actually, this one we could probably optimize that. But with
hold on, I think this is not going in the right direction. Okay, so one thing you could do is you could make g of x blank be a type, and you could do everything with types.
That's what I was saying here. You see,
right?
If we made it
but I think there's an alternative.
It would do that.
Yes, I know, but I think there's an alternative, which is to think of factoring this operation into two pieces. One is the unrolling of down value assignments into lambdas, and the other is essentially having a procedural pattern matching step. I think, and I'm not quite seeing how to do that.
But by the way,
the pattern matching step is procedural, because the pattern matcher tries, rules in order.
I know, but that's not the point I'm making. The point I'm making is.
Do you mean that is runtime pattern matching in compiled code?
That's what I'm saying. Yes.
Yeah, because we can compile patterns.
Yeah, we've got code to do that.
Okay, but so hold on. But let me understand. So the first thing, which is an interesting thing that you're demonstrating, is taking variables whose types you know, or arguments whose types you understand, and creating. Let me look at the lambda you created for that test fund thing.
This thing.
See, how does that work? How does it do the different cases? How does it do
it's
the
just
minus
a witch.
3?
There's a witch.
Okay. All right. Okay.
And it could do something else cleverer, because you have to look at this is helpful to look at, because the down values, right? I'm using them in the order in which the down values, which obviously is the right thing. But we could do cleverer things like this and this. We could do.
Okay, you can optimize separately.
Like hash table dispatching over literals, which the current pattern match doesn't do. So if you had like 1 million of these, it does them all sequentially.
No, it doesn't.
People that write alpha discover this, and then they have to go and rewrite their patterns.
Excuse me, it doesn't do that. It doesn't do that. The down value, it absolutely does not do that.
No,
the down values are optimized.
It does do that. I've checked this very carefully.
Okay, it doesn't. If it does that, somebody ripped out code that's been there for 30 years.
Never had that. I'm talking about individual. You see, like inside one pattern, it does that, but not for different values.
I'm sorry, it's just nonsense. I mean, if I say f of 1, f of 2, f of 3, f of whatever, that is absolutely a hash dispatch.
Right, absolutely that. But that's not what we have here. We have x blank. So if you had f of x blank comma 1, f of x blank comma 2.
You're absolutely right. You're right. You're right.
But that's an important case. And alpha people discover that,
Okay. Tom,
we can do that,
Tom, I understand. Yes. I understand. So what you've got is you're thinking of the down values list, and you are compiling that in a very Wiccan kind of way, into a witch. right?
Yes.
Okay, so now let's try to understand if the arguments inside there were, instead of that being test fun of x blank, y blank, it's test fun of g of x blank. Doesn't look hopeless to compile that.
No, it's not hopeless at all. Absolutely. I utterly agree. It's
right.
super
So
interesting.
in a sense,
I just didn't do it.
Okay, hold on. So what you would turn that into is a which in which there are match queues. Instead of -1 equals value, whatever.
Yes,
just a match.
And ultimately, I mean, that's ultimately what has to happen. I mean, the issue is that right now, you can compile some patterns, but also it takes it, it takes it a million years to compile some. And so it's not super practical.
Okay, but
but for things like startup code, we could do this, and we could make a compiler fast.
Just to understand
technology like this.
So there's also the case of what do you do when the function has different, if there's different usages that, for example, take different numbers of arguments, or just
that's why that doesn't happen in this thing here, because I gave a type to it, and so it just picks up the ones that have 2 arguments.
Okay, but in the more general
so it knows
case,
which ones it can work. It has to work.
Okay,
and I mean, it doesn't even have to be. You could have 2 arguments, but one of them could take integers, and one of them could take expressions, and one of them could take.
Absolutely, there are this could be extended in many ways.
So
but what I was wanting to use it for, this was astonishingly useful. But absolutely.
So for example, if there are double blanks and things like that, what you would have to have here is, I mean, I don't quite know how that works in terms of the function. What is the named argument version of hash in a function?
Right.
How does that work?
There isn't one. So
okay, so we'll have to invent one.
Yes.
Okay. So, but that's going to be okay. Hold on here. So,
well, sorry. I mean, can't it just bind it to an expression that contains a sequence or something?
Yeah. Well, that's what it would be.
Yes.
Possibly. Okay. But so then, what you're showing here is something that has proceduralized the assignments, which then gives you a fighting chance of just using traditional compiler technology to compile the whole thing, which is great.
Yeah,
which by the way, though, I mean, I think if you could really compile patterns, then the which statement would basically just be, does this match the first pattern? If so, call the first, definition. Does this match the second pattern, and so on?
It could be a switch.
Well, it could be a switch.
Fine,
I mean, more generally, the point is that I think it turns into, kind of a map thread kind of thing. It's right. I mean, I think that the ability to convert the patterns to a which statement is kind of just a result of the fact that we can't really compile patterns efficiently right now.
Fair
enough.
Well,
there's particular sorts of patterns where the match queue has evaporated into things.
Well,
I mean, if you went to look at the actual...
we have pretty much the full pattern language compilable. It's now the implementation is fairly naive, and it isn't quite as fast as the kernels because I wrote it and it's naive. But other than some corner cases and a few things, you have almost everything you want. So
what you're saying, Andrew, is that if the original declaration, the compiler environment append to, contained expression types there, that then the actual down value list, which includes could be compilable. Is that right?
Yeah, I mean, you can turn those expressions into compiled expressions. You can compile them and you can match against them. So you can do these things.
I think that's true. Yes. So sorry, I'll take out that. I think that is true. Yes, we could do quite a lot if they were expressions.
Right. Okay, so hold on.
The right hand side could call the evaluator. I mean, and this would be correct. There'd be no, not working or working, because we would know what was.
Okay, so what you're claiming here, right, is that my claim about sandwiches is unnecessary. That your claim is that given a down values list, that you could use this technology to turn it into a pure piece of compiled code, even though that compiled code might have to contain evaluator callbacks for some of the down values. Is that correct?
I think this is true.
Right.
I think this is true.
And basically just that the function dispatch would be written in the compile, it would be compiled.
Right. Which is great.
Yes.
That's fine.
Yes.
So just to understand here, like that which or the switch, one could well imagine that there are all kinds of optimizations, even from Boolean function types of things.
There's endless. These are like fantastic. Absolutely, absolutely. Yes, yes, yes.
Okay, but so just to understand the status here. So we could actually make something, you're saying, that would take any down value list, and I just want to understand what the syntax is going to look like. So it would take any F, and it would allow you, what would it actually look like? Okay, compile down values. Isn't it down value?
I don't know if that's the right. I'm just.
I thought down values didn't have a capital V. Am I wrong?
Down values has a capital V.
Oh, sorry. Okay. That just looks blue, so it looks wrong because
it looks blue because it doesn't have a color. Yeah.
I know.
Notice, here's another weird thing. When I did this, okay, it when I did function compile, it clears the down values. So it just goes straight to the down code. So it lost the coloring.
Oh, well, that's a bug which has to be fixed.
Well, fine. That's yes, yeah, a missing feature. Yeah, absolutely, yes.
Okay, but actually, it isn't a missing. What you've done here, I just want to understand how this works. You have taken down value processing.
Now, if I do this now, it's oh, hang on, what have I done? Oh, I don't know what I've done.
Can we please just walk through the workflow of this?
Oh, I know what I've done. Right, I've made a compile. There's another thing that you need, which is you need to install. I haven't installed this as down code for test fun. So that this is a bug actually. Basically.
Okay. Hold on.
Yeah,
okay. Yeah. So you've got one piece of functionality that takes an F of blank, pattern type thing, and wraps it all up into a Lambda, basically.
Yeah. And then compiles that. Right.
No, wait a second. There's one piece of functionality that will take an F of X blank, blah, 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 and turn it into a pure function, right? That's one piece of functionality. It has nothing to do with the compiler.
Yes. Although I would argue that, again, if you have a fully function pattern matcher, then that operation is pretty trivial. I mean, here it's using which makes it less trivial. But if you had all the patterns and it was cheap to compile them and so on, then that would be pretty trivial.
Syntactically non-trivial, because you've made assignments, F of X blank, blah, 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 blah. It's syntactically non-trivial to do the wrapping. I mean, occasionally I do it, of taking an F of X blank, blah, blah, and turning it into a pure function, but it's a pain to do that.
Yeah.
Am I making sense? I mean, it's just syntactically, those are two different branches of how one thinks about
it's a nuisance, right.
Yeah. Right. So there's value to being able to take that and just have a function that goes from down values, and I'm not even going to ask about sub values yet, but I think we should be thinking ahead to sub values. Have you thought about sub values?
Well, I mean, sub values in a sense don't really exist, but you're not going to like answer. But they're just extra arguments in the magic.
Yes, that may be, but okay. So, but so one thing one could imagine is something that simply takes any list of rules represented by down values and turns that list of rules. Here's the point. You want a function that's called something like replacements to function. That's a bad name. Do you understand what I'm saying? So you can take that list of down values, or for that matter, any list of pattern matching rules, and turn that list of pattern matching rules into, now there's a trickiness.
That's otherwise known as, there's an existing function for that. It's called replace.
No, but I understand. This would be the equivalent of replace, but it would be something which can explicitly take this. But you see, there's a trickiness here because you've got that thing called test fun in the middle of this.
The only difference between this, that conversion to this function replace is just the fact that, this is sort of writing out a procedural program to do it as opposed to just doing it.
Yes, I agree. But there's a value to having that procedural program which you can then do things with. I mean, but as I'm saying, it isn't quite the same thing, because inside that down value list, there is a test fun hold pattern of test fun, blah, blah,
But
blah.
there is, yes. Yes.
Right. Whereas, so in other words,
In a sense, the name of this is test fun. You see, that's
right.
the
So let's
name
just
of this
understand
function
what
is
this would
test
be.
fun.
So what
Yeah.
you're saying is you're taking that list there, and what you're saying is make a function which is the equivalent. It's like solving an equation. Given this list of rules, apply, let's say you said replace of all of that. Okay, so they just you're out 18. Just take out 18 and just type replace of all of that. Just copy out 18. Copy that and type replace of all of that. Okay.
And
now,
replace what? Like
no,
whole-
close
the
the, no,
operator
no, no, no,
form.
no, no, don't
Operator
replace
form.
anything. Just close the bracket at the end.
Right.
Okay, okay. So now that form, now apply that to test fun of 1 minus 1 3. Okay.
There might
Now
be some
run.
issues with holding, but yeah.
No, it worked. Okay.
Well,
so
it
now
might have
what
evaluated the test fund, but yeah, I mean,
okay.
fundamentally that does work.
Okay. So now what I'm saying is what you want, and it's sort of solving an equation that takes, yes. So that is applied to minus 1 3, not to test fun 1 3. Okay.
Yes,
So
and we get the same answer. Right.
Yes, I know. So my point is, there's an operation here which is taking that thing with the function embedded inside the list. I don't quite understand how this should work. I'm looking for a function. Okay, and then what you've got to do at the end of this, you've got to reinstall. So you've got these 3 things that you can do. You've got replace with the explicit function in there. You've got the pure function, which just goes inside the test fund to take its arguments, to steal its arguments away and do the evaluation. Okay.
Mm-hmm.
Then you've got case number 3, which is you want to write back into test fund that direct steal my arguments and evaluate thing. See what I'm saying? Right. So that's test fund equals that function effectively.
Well, let's call it test. Yes, right.
No, that's what it is. That's what
Right.
it is. That's what it is. Now, okay.
No.
So hold on. Yes. So that should just work now. Okay,
Yep.
great. Okay. So now what I'm trying to understand is you've got, okay. The first step is to take your set of assignments, because what I'm worried about is this, okay? It's not going to work to just, okay, so you've got a notebook or a file that has a bunch of f of x blank blah, blah, blahs in it, okay?
Right.
Then you compile. Then you change one of those f of x blank blah, blah, blah.
Yeah, right. Well, that's absolutely, yes.
Right? So let's just understand what we want this to look like in the end. Do we want it to be the case that you make those assignments and then, see, this is sort of a meta assignment that you're making in the end, right? You have a meta assignment, which
Right.
is actually take all those assignments and repackage them as a compiled object.
Mm-hmm. Mm-hmm.
Okay, so do we have any analogy for meta assignments? It's a little bit like attributes, isn't it? Except that attributes, we have the kind of the sort of the lazy rule that you have to set attributes before you start making assignments. Do you see what I'm saying? In other words,
Do you?
assignments
I didn't
would
know
be
that. You can. I thought you can make assignments and then set an attribute.
Nope, I don't think so. I mean, maybe
Well, it
somebody
depends what
fixed
the
that in the
attributes
intervening
are.
30 years, but
Depends what the attributes are.
I believe that the pattern compiler, if you post set the attribute, the pattern compiler does not know to do
for things like one identity and flat. Yes, that's true.
Right.
Non-pattern matching attributes. That's
Yes,
yeah.
that's right. But I mean, the fact is that this is exactly the same situation, right? That is that the
But this one you want to do it at the end.
yes, that's the point I'm making. So, but you want to do it at the end, but when is the end? Because you might go back and and edit the code.
Right. So
You could
maybe
say-
the thing is it should somewhere keep the down values and
Absolutely,
basically
yeah.
if you add another one, it's going to recompile or something.
Yeah.
Okay,
Could
so
do that.
then let me suggest perhaps the right thing to do is to treat it like an attribute that says every time there's an assignment here. See, but that's a bit funky. I mean, one thing you could do is say set an attribute that says every time there's an assignment, do a compilation. So
And in
set
particular, you
attributes
could get
to
it to just
auto-compile.
you could get it to just compile the new assignments.
I would
too.
call it
So, yeah.
auto-compile. I would call it auto-compile.
Okay.
Auto-compile. I mean, I think that's
Yeah. I'm just typing.
okay.
Right.
Okay. All right. But so then what that would do. I see. But you're saying, Christopher, the new ones, but I don't understand how you graft the new ones onto the old ones.
Well, I think one way you could do it is just that each down value is compiled separately, and then you compile this one pretty small dispatch function that calls out to them. And then when you add a new definition, you need to compile the new definition, and then you need to recompile the dispatch function. But hopefully that doesn't take very long.
It would
I have a feeling that you don't have enough control with this. I have a feeling
have
that
to
you
rebuild the because you might reorder. Adding a definition might reorder the down values. So you probably
right.
have to
I have a
rebuild.
feeling this is not enough flexibility. I have a feeling that instead it should be more like a one of your type declaration type things for test fun, because I think you're going to need a bunch of options. You're going to need all kinds of type information.
I tend to agree with that.
So then the alternative, which maybe was what you were going to anyway, Tom, was some declarative thing about test fun. Is that what you had up
Well, that's
there?
kind of what this is, actually. So that's what this is. And this was sufficient for what I wanted to do.
Okay, all right, fine.
Well, but I think that's that. I think it should not be inside of something like compiler environment depend to or function
No.
compile because those are for modifying compiler environments, not for.
No, but it
this.
has modified. That means if I write another function, if I do this, well, I've
sure you can use test fun. Right. But I mean, I think,
fun.
but it's also
absolutely correct. Sorry, it's absolutely correct.
No, but it's also changing the behavior of stuff in the evaluator, which compiler environment.
No. This hasn't changed the evaluator. This in itself
but it needs to.
has not changed. There's other.
Right, but that's the whole point.
Thing.
One needs to change the evaluator, right?
Absolutely.
So what I think.
That's a
okay,
different
so
step.
I think
Right,
what it should be called is something like set compiled, set auto compile or something.
Yeah.
Just write that down. Just something like set auto compile of test fun.
Right.
And that with a bunch of random, parameters there.
Right.
Type signatures and things. Yeah.
Yeah.
Right. And so then what you would do is if you say set auto compile, and then you give a bunch of definitions, it would have potentially heuristics to decide when to actually do the compilation.
So you put the definitions in here?
No, not at all. Not at all.
Right.
You've got the definitions. The definitions are things that you have developed over the course of millions of years, in pure evaluator code, right? And then you say, oh, I think I know what I'm doing now, or it's not running fast enough. Let me set autocompile on this function.
Right. So the 0th thing is probably if you just say set autocompile of test fun. The next one would be if you give it a type.
Exactly.
Yes.
Yes. Set autocompile of test fun. It will try and do its best, doing essentially expression compilation. And okay. And then what happens is, and then presumably there's a clear autocompile.
Yeah.
Now the question is, what does it look like? Right. What does it look like after you've set autocompile? I suspect what should happen is if you've set autocompile and you ask for down values of test fun, that what you should see is the first argument, the first entry in down values of test fun should be some weird compiler call thing.
Yeah, except it's not really a down value. I mean,
I know it's not a down value, but you have to store the information somewhere. Right? The down values have become vestigial at this point because set autocompile has trumped them, so to speak.
Yes.
Right.
So what would you want to see in the down values?
Well, I'm saying that I think that, for example, when you say clear autocompile, okay, so first of all, the down values will continue getting updated if you reset test fun. If you set new values in test fun, the down values would continue being updated along with whatever autocompilation has to be done for the first, for its autocompile, right?
Right.
So that means when you say clear autocompile, all it does is to throw out that first special hook in the
I mean, internally,
and
that's
down
probably
values.
not what it does, but
No,
visibly,
internally
yeah.
wouldn't be what it does. But so then
But this would restore it back to the state it was in. So
right.
yeah.
So what I'm suggesting is that the first entry in the down values list would be something that says, something like blank. Can you type one? Just take your down values list from above.
Yeah. Hang on.
Just, okay, right.
Right. Okay, we've got this.
Okay, all right. So now what I'm saying is that the first entry should be, blank arrow or something, blank colon greater than.
Compiled code function.
Yes, basically. Right. I mean, it might need some additional decoration, but that's what I'm basically suggesting. And that then the
except
control.
Usually, yeah, yes, okay. Except obviously that's not really being run. We might find problems with this, like people are hacking down value lists and relying on them.
Well, okay. So the question is, how do you maintain? Okay, so here's an alternative. Okay, actually, this is a better idea. Just reset the down values instead of being that list that can be used in replace. Just reset the down values to some other function that contains inside it the original down values, but has some wrapper that says, just write no, outside the list, outside that list, outside the big list there, just outside that list, just put in something like but before the big list, say something like, compiled down values. Okay, now, and then the comma, and the first argument of compiled down values would be the compiled code function or something like it, comma, and then get rid of the blank arrow, comma, and then the old down values list. So in other words, when you say, what is the value of down values? The answer is it's compiled down values.
So you're saying
that's a little weird
values,
though, because I think that I can imagine there being code that kind of, sort of relies on the fact that it's a list of rules.
All right. Well, in that case, you might have to do something where instead of being blank arrow CCF, it's something like, I don't know exactly what it should be then, but either way, the basic
could
work
be something like this.
X blank Y blank.
Yeah.
Yeah, that'd be okay.
Well, no, sorry. It's this.
Yes, that's fine.
That's
except without the minus.
Except
Yeah,
without the minus.
that's okay. And I mean, maybe there's yeah, why not? I mean, and if somebody's really going to go monkeying inside the down value list,
Okay.
they'll have, they'll get what they get. And it won't be completely crazy.
And
The only thing that will happen is that first, entry will shield all the other entries if you run replace.
In fact, in reality, the down values will be this.
Well, reality, I'm talking about what.
I know you're talking about what people see, but in reality, the down values have been cleared.
Except that you've got to store the original down values somewhere because people.
Yeah. There'll be yes, absolutely, yes. There can be a store. There will be a store for that.
Well, I mean,
I've implemented some of this, not this stuff with down values and everything.
Okay, but hold on. I mean, I think as a practical matter for safety, the down values should still be there. You can put an internal flag to which you can immediately check, so you never have to actually look at that list.
Well, I think okay, fine, right. That's detailed.
In fact, what I would do.
What color is the font? Yeah, that might be sensible. That might not be sensible, but yes,
okay, all right, fine.
Absolutely.
But let's just understand the workflow then. So you type, you type in all your assignments, then you say set AutoCompile on that function.
Right.
Okay. Might even be set compile. I'm not sure. You could just put that somewhere else. That's. I mean, I'm just not sure.
So set.
Either set compile or set autocompile. Maybe set autocompile is clearer. It depends on the semantics of when it redoes the compilation, so to speak.
Right.
Okay, but so then set autocompile would mean whenever I type a new assignment. So if I've got a loop and I'm typing in assignments in the loop, I'm pretty toasted. You see what I'm saying?
Yeah, then you probably want to do.
So for example, if I have
make
memoing
assignments and set.
I know,
you know.
but what if I have a memoing function? Do you understand what I'm saying?
I mean, maybe sometime we could have something cleverer for memoing functions. We could recognize this is a memoing function.
Yeah, all right,
That
okay.
might be neat.
Yeah.
Right, but the
I mean,
first
for
step
now,
is
yeah, right. For now, it ain't, it won't, I mean, it won't be, it'll work, but it won't be super efficient. I think if we had some clever thing for memoing, I'd love that. That would be fantastic.
right. Okay. All right. Okay. But back up here. So to me, this seems pretty sensible. Is this within what you can implement, Tom? What we've just discussed?
I can implement anything that doesn't violate the laws of mathematics and physics. Quite a lot of this I can implement with the tools I built.
You shouldn't
Some
go there.
of what
After
you're
all the
asking
stuff I've been
for-
studying in mathematics, it's not clear what that statement means.
Okay, fine,
Anyway.
right. Well, that's a fascinating conversation. Yes, right.
Yes,
absolutely.
but
I'd
not
like
relevant to
explore
this.
that. Not right second. I mean, I was being flippant. Some of this involves kernel changes, and they're kind of slow and ornery and everything. But I'd be
Let's try and
interested in
get
having a
something.
go.
Does everybody else agree that this is a basically sensible design?
Yeah, I mean, I think something like this sounds
I think
Yes.
there's
good.
going to be some hairy edges, but I think
Yeah.
I'd be pretty
Right.
pretty chuffed. to
Okay,
get,
so
you know,
Andrew has enough of a pattern compiler that this stuff would run. Is that correct? It may not be
Yes.
as efficient as it could be, but it will. It's
yes,
basically going to
now
work.
these things are. Let me warn you, these things are dog slow to compile. So
Well,
you know,
that's a problem that has to be
That's
fixed.
a problem.
That's the real
We
issue.
should
I mean,
make the compiler faster. And,
right. I mean, the
right.
compiled patterns, when you actually, run the compiled patterns, they're a bit slower in the evaluator. But the real problem is that, like, I mean, I think now there's some mechanism where some parts of them are sort of pre-compiled and stuff like that.
Yeah,
I remember the example I did, when I first did this, I just did match, match of blah, 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 comma, underscore. And that took like 2 minutes to compile.
Yeah,
Yeah,
they're very slow. Right. I mean, I think the
Okay.
thing I should really work on is making the compiler faster. And
No, you should really work on getting this workflow so that we know what we're aiming for.
yeah, fine.
Then you
okay.
know what you're making.
I'll put some work into this. This
Okay.
sounds great. I'd like to do
Okay.
that.
All right. So just so I understand, the actual compiler, the compiled version of the patterns, what's involved in making that faster?
So sorry, I'm not sure what you mean. You mean
Well, you say
Making
the
compilation
runtime.
time, that 2-minute compilation time, making that faster.
Well,
My guess
I'm
is,
asking two questions. There's that, and there's
Yeah.
also, once the patterns are compiled, the runtime of the patterns. What's involved in making the runtime of the patterns faster than the evaluator pattern matcher?
Yeah, I think that they need some work. Well, first of all, is being able to recognize that you can do things like this. Okay, because if you can do this, you're always going to be tons faster. And the other thing is it just needs sort of study and work and such like.
Well,
So-
I mean, the original optimization of the pattern matcher is probably still my code from millions of years ago.
Yeah.
And it's, I mean,
I think with, Andrew worked on this. It was a sort of, proof of concept, but it worked, and it's just matching
Well,
against the
remember
expression.
when I say it's when you say it's slower than the kernel evaluator, it's the same order as far as I can
it's
tell
not-
for everything. It's like
Yeah.
a factor of 1.5.
Yeah, it's something like that.
So it's like
not
it's very
ridiculous.
serviceable. It's just that
Yeah,
if you were writing
I-
code that was all pattern matching, you'd be disappointed when you
I doubt
compiled it.
that's true, Andrew, because I think that
No,
when you get
I
into
tested
triple
it pretty
blanks-
well.
Okay, but when you
common
were
cases.
enumerating triple blanks and things like this, does it know how to cut those?
Yeah,
cases and
probably
things?
not. No, I don't. I don't.
No,
think
but
it-
then the kernel doesn't either.
Oh yes, it does for many
It
cases.
doesn't.
Well,
no, we can debate the corner
Right,
cases.
I think the runtime issue, I think, is not as bad as the compilation time issue. I mean, I think the compilation time issue, thankfully, I'm pretty sure the reason the compilation time is so slow is because it does a bunch of stuff with union types, which right now are generally really slow, but also should generally be sped up because they'll be useful for lots of other things.
Yeah.
So-
They're not really slow, but yes, there's optimization. The other thing, let me point out that this will make it win is that when you're processing a whole sequence of down values, that's going to be beneficial, and that's where the existing pattern matcher sort of loses out, I think. So
can I ask a very practical question? So if I'm using this stuff and I've got a session and I want to compile things, and it's going to take 10 minutes to do a piece of compilation, or 30 minutes or whatever.
Yeah, it
But
would be entirely feasible to save your state out and reload it. Absolutely, yes, that's important.
Well,
using dump
obviously.
save or something, but
No, but
Well,
why do you have to use dump save? No. The whole point is you've got a serialization of the final compiled function, right?
yeah, we have quite nice ways of serializing these guys out.
I know. So I'm just
Yeah.
saying that whatever the serialization is, let me just think about this for a second. What I'm just trying to understand is, after you have, let's see, normally you've got a notebook. I'm trying to understand this workflow. Okay, do you understand what I'm asking? What I'm asking is this: you've got a notebook, you've got a bunch of assignments. Usually, the workflow is you reevaluate those assignments when you come back into that notebook.
Right.
See what I'm saying? But if it's going to take 5 years to do that, that's not going to work.
Right.
well, I think dump save is not that unusual. Dump save and get, because that's already what you do if you have, if you have a bunch of data you're computing or something like that, and it takes 10 minutes.
Well, also, yes, or if you're creating an API function, though, that uses that technology, does it not? Or doesn't it? It uses WXF. Well, if you created an API function from a function that has been compiled, how does it get the compiled version?
What do you mean API function?
I mean, a cloud deployed API function.
Well, you would just send the CCF.
No. Let's say all you've got is test fun, and you've just given the code. I see. You're saying that what would happen is it would automatically work because it is doing a save definitions and it's picking up the down values of test fun. Is that correct?
I think that's an important point that we should. Yes.
Right, but so long as save definitions works, I think it will work. I think that will just work. Okay, but the case that I'm addressing is the following. You've got a notebook. It's got, usually, you consider it a zero-time operation to just reevaluate the initialization cells in the notebook. Okay, people don't worry about that time, right? But if there is recompilation involved, it's disastrous. The problem is that set AutoCompile doesn't have a savable side effect, right? It's just changing kernel state.
But again, I don't think that's that bad, because it's how it already works with data. I mean, there's certain, like when you make a big notebook where you're doing long computations, there's some cells like setting definitions that are like the cheap ones that you just do every time, and they're the expensive ones that you save out in some way. Or iconize.
Well, maybe we need to think through. Maybe we need a separate discussion.
I think we need a separate discussion on this. I think if we could automatically save things in the notebook somehow, so they could be rehydrated somehow, that would be pretty powerful.
Right, but
it is more convenient.
Right, but so let's have a separate discussion. I mean, iconize was a great innovation, and what you're saying is some kind of auto iconization method. That's.
I mean, it might be nice to have a general kind of dump save plus iconize thing. Not sure exactly what it would look like, but I mean, just something where you basically you save, where it's just, I want to save these definitions to a notebook.
Yeah, I know. So let's have a separate meeting about that.
I mean, there's import export and then there's dump save get, right?
Let's see. I think Aubrey is PMing here. Can you make a note for a separate meeting about that?
Sure.
Okay. All right, let's go back here. Let's go back to Christopher's. No, that was very useful, but let's go back to Christopher's.
Good.
All right, so I think we were talking about, let's see. Yeah, we were talking about the compiler interface stuff.
Yes.
Right. I mean, so basically, so the first thing is that one alternative to this would be to just sometimes there are puns where you can kind of say, well, this onFree function is a little bit like, it's a little bit like maybe you could define something for delete object and the compiler calls delete object whenever the thing gets freed, or there's some things like this. But honestly, I don't think that's a great design, both because one, there are some cases where there isn't any clear pun, and two, it'd be very hard to document them.
How are you saying? I don't understand. The function declaration how does it attach itself to something? That's just saying on free. How does it say what the data structure?
Okay, so basically, what
Give it time.
realistically is
Give
going to
it time.
happen is that
Right.
when the compiler is trying to create, for example, in this case, the compiler is trying to create this wrapper that takes, that it has your function, then it will take the output of your function and convert it to an expression, right? When it compiles that wrapper, it's just going to compile some function where this function is used in it, right?
Yep. For those.
And so
types.
if there's a definition, right?
It
If
will
there's a
pick it up.
definition
Right.
for your type that if that function has a definition for your type, then it will compile. If that function doesn't have a definition for your type, then it just won't compile.
I'm sorry, I'm
Right.
totally confused. Are you saying there's a single central function declaration for the compiler interface of to expression, or there's a
Yes.
separate one of those for each struct?
No, sorry. So there'll be a separate one of these for each struct, right? But the point is, where will this actually get used? This will actually get used because somewhere there's a function that's going to get it's going to get used because somewhere there's a single function that's going to get compiled every time that you make a compiled code function, and that single function is basically the thing that converts the output of your compiled code function into an expression. And and that single function is just going to be basically a call to this, right? And so then if this has a type signature that matches that usage, then it will work, and otherwise it won't, if that makes sense.
I
mean, it's the same thing with this. I mean, basically what the way it will work is that, right, when an object's ref count goes to 0,
yes.
right, there's some function that gets run, okay? And in the middle of that function, imagine here's the function that gets run. My keyboard is, okay, yeah. Here's the function that gets run when something's ref count goes to 0. It says, oh, I'm gonna, it takes the object which has some type, and it's going to say, oh, I'm going to do all these low-level C things to handle that memory. And then, by the way, I'm going to call the user-supplied function for freeing this stuff. And then I'm going to do some other stuff.
It calls that. There's a default version of it. So it always.
I don't understand why obj isn't on top here. Why it's on free that's on top of obj, rather than it being. I mean, it's almost like what you're saying is, we have all kinds of crazy things like format values, where it's format values of f : equals blah, right? And you're basically saying the on free value of obj is blah blah blah. That's the syntactic form that you have here.
It's kind of what this
the
is.
Type. It has different type, then the type needs to be in there somewhere.
No,
but
but
if you
might have different types. You see, it might be polymorphic. So there are many different versions of obj if it's polymorphic.
No, I realize that, but what I'm asking is, I'm a little bit confused by why obj isn't on top. Why it isn't the case that this is the on free quotes method of obj, rather than saying that it is the on free value of obj.
You mean something like obj of on free?
Yeah, it's not quite that, but I mean something more like that. That is that rather that, but not. I don't know whether that's the core. I'm saying, what's the assignment? Why isn't it that it is a decorator of obj? Why isn't obj?
You want to be something like something like, well, okay, it is the thing in charge. The alternative to say on free function of obj open close. That would be the equivalent of the top level, with like format or something like that, right?
Okay.
But the point is that, and that's exactly what this is. It's just that, basically, if there are going to be 10 of these and they're
okay, all right. So then
this is not nice.
Okay, so but if it was called compiler interface function, if that was its name, if it was called compiler interface function, and then and then there are multiple kinds of compiler interface functions on free blah blah blah, and they take in a curried way perhaps. They take obj and then they take the payload, which would be an open close in this case. That makes sense? So in other words, you're saying...
Yeah, I mean, I'm not sure that there's always a single object that's like the thing, right? I mean, in these 3 examples, there is a single object that's like the thing that you're, like basically what these are callbacks for when certain events happen. The 3 events I've listed here are all have to do with a single focal object, but I don't think that's necessarily the case.
So you're saying that there can be a globally declared event, like on quit or something, that is a
Sure. Yeah, I mean that would be a reasonable one that probably should exist. Yeah, on quit
right.
or on startup and etc.
Well, we have
Okay.
initialized functions, by the way. That's a
Right.
bit like
No, but so
Fine,
what
yeah.
you're saying is this is a thing, and I don't think it's clear from the name. This is a thing called by the compiler. I mean, it's like a handler function of some kind.
yes.
Right. It's a lot more global than that.
Yes.
There might be some other better names than callback interface.
Yeah. But okay, so what this is, I'm still trying to understand. Sometimes it can take so it's a little weird that sometimes it can take an OBJ subvalue in the sort of subvalue position, and sometimes it doesn't. What would be, could you write what you think the compiler interface of on startup would look like? Is a compiler interface of,
well, the way you would define, I mean, really, this is not the case to look at. The case to look at is where you actually define the behavior, because that's the only thing anyone should ever do, really.
Correct.
So what you would do is you'd do something like this. You'd say on startup or something, and then you'd have your function.
why is that inside function declaration?
Because this is a function. So this is a
declaring the
function. This is the name of the function, right?
I see.
That's what's happening here too. This is the name of the function.
But
you're
usually a
calling.
declaration does not talk about actions. A declaration is merely a type specification. Whereas
Right.
here you're saying,
Exactly, but that's only because the whole point. Well, actually, that's not entirely true. I mean, the point is that somewhere there's a piece of code, like there's a piece of code that'll get compiled. But basically, the point is that there are certain cases where so okay. Let me give you an example.
Well, hold on a
Let's
second.
say
I was just gonna say
I
something.
define
real
a
quick.
new. Sorry.
I was just gonna say,
Yeah.
to wit, Java, the declaration and definition come in the same statement. It's C where you declare and define separately. So we're just more Java-ish in this sense. When you declare the function, you include its definition.
I thought in C, in modern C, in the C that I always knew, you could have a, but I thought that in more modern
You can
Cs,
declare and define at the same time. Yes.
You can get away with that, yeah. You don't have to though.
right.
But okay, but the point is, let me give you an example. Suppose I define a new type, a new object, and I'd like to be able to define how to cast between that object and some other objects, right?
Yes.
The way you do that is you say function declaration. I'm defining a new cast, and I give it some type, right? And I give it some type that's based on my that uses my new type, and then I give it a definition, right? And now if the types align, just like defining a new down value, then this is what it will call.
I thought a
Okay.
declaration, a declaration contains actual code to run. Is that true?
It is. It's there.
Yeah. Yes. There'd be actual code here, right? Right. And
I
so the
see.
point is, this is exactly the same thing, right? So just
Why-
as in this case, basically what's happening is you're saying anytime someone calls cast, right? If they happen to call cast on my new type, then this is a definition to use. This is exactly the same thing. This is saying if someone is ever happening to compile a piece of code that needs to convert my type to an expression, then this is the code to use.
Okay, but is function declaration like an assignment, or is it something that's symbolic, that's inside some other outer
It's like an
Think of
compiler
it as an
environment?
assignment. Think of it as an
It's an
assignment.
Yeah.
So it happens at the time you type it.
Well, it happens when you put it into
When you-
compiler environment append to.
Exactly.
But I mean,
Yeah,
it
precisely.
is itself inert, but it'll almost always appear in a position where it's being put into action.
Okay, but its name suggests inertness, and it is in fact inert because it has to be hydrated. It has to be activated by something.
Absolutely.
Yes.
They are potential functions. When you write it polymorphically, especially, it's a potential function, not a concrete function.
Okay. So people will typically have code that has a bunch of function declarations, and then they'll have a single compiler environment append to. Is that right?
Yes.
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 I think so. Yeah.
Correct.
Okay. All right. Okay. Well, this seems reasonable. I agree that your compiler interface name is, I think it's right to have a single name and a bunch of string cases there. I
Good.
can't think of an obviously better name immediately.
Yeah, I mean, I think
even-
callback is honestly a little bit better than interface, but it's still not
Really?
totally clear. I mean, I think a third would be even better, but I think, I mean, I just think that interface is a little bit generic, but yeah.
Yes, but I'm concerned that you're going to end up wanting something. Okay, so the issue is here. Well, what this is it's a function to be called by the compiler upon an event.
See, this
right?
seems more like, in this case, it's an object interface versus, and I mean, obviously some other things like on startup are a compiler interface or a, well. they're a
Well, are you
module
arguing,
interface.
Andrew, that there are two different categories of thing here?
Yeah, if you
Yeah.
if you want to just use a generic-y name like compiler interface, it's not the worst thing in the world.
But
But
the name
these are
goes
a
in
little
the
more
string.
specific. I mean, there are different categories of these kinds of interfaces, so we might have more specific names for them.
But that's in the ontology of the string that's in the payload of the thing.
Yeah.
Yeah, I mean, I have no objection to a compiler interface. I'm just pointing that out.
Right. Okay. We are officially out of time here, but can you give us a preview of
Yeah, okay. Well, there's this stuff about expressions, which we've mentioned last time, but still haven't gotten to. There's this stuff about the potential for this other function that's a little like create data structure, but a little bit different. There's the stuff about basically dealing with dangerous, heap allocations in a way that isn't dangerous. And then the new stuff is, this one is a quick one. Basically, it's a function or a symbol or something for getting you the return type of the current function, which is something you actually need because you can have type signatures like this,
Yeah.
where basically the return type is not determined by the input types, it's determined by what
So
eats
you don't know what it is. Yeah.
Right. So you need to be able to query that. But
why
this
is
is
it
just a
sort of
naming
an
question.
automatic as the return type?
No. So the issue is that I'm writing a function, and let's say it takes no arguments, and and it does whatever it does. But then the point is that this function can have, depending on what eats this function, it can have different types. So for example, I might have, this one is not a great example, but I might have multiple definitions of range. So that range, depending on what eats it, it could either generate a list vector or a packed array, right? Because maybe the thing that eats it only eats packed arrays, and so that's what it should return, but maybe it only eats list vectors. And then, so that's what it
I'm
returns.
sorry, try this again. I'm not understanding.
Okay, when I call range, so
Yeah.
suppose okay, let's say I have two versions of range. One version that returns a packed array, one version that returns a list vector, some other list-like thing, right? These are both reasonable type declarations for range. So how would I do that? Well, I'm going to have two definitions. I'm going to have, I'll have function declaration of range, comma, typed this, and then some definition, right? So let's say this is the first one. So it takes the length, and then actually, sorry, this is not the, well, okay, yeah. Actually, this example, sorry, this example doesn't quite work well because it can't be. I can't write like I can't. It's hard to write with type for all in this case. Let me do a different. Well, okay. Basically, the case is that I'm going to omit the type here for a second, but just basically know that we're going to have something goes to a packed array, and then I'm going to have another declaration where it's
something that uses a bitcast. Put a void handle in there or opaque pointer, and then you do a bitcast.
Right. Okay. So basically, the point is that you can have functions. Okay. Here's an example that's less intuitive, but actually works. So toPointer, returns a pointer, takes no argument. If you give it 0 arguments, if you just do toPointer open close, it returns a pointer to a t, right? But there's no t in the inputs. So how does it know what the t is? The answer is it knows that by what eats it. right? So if I call two-pointer on its own, it's going to be confused, right? Like it's going to say, I can't figure out the type of this. But if I say x equals two-pointer, and then I say call my, let's say there's some C function, I say, library function of, who knows, I'm calling some C function, and I feed it x. Then because it knows the type of this function, it knows that, well, in the first argument, I'm going to take a pointer to an integer 64. And so it now, and so that's how this works. So the point is that in the source of this function, if I need to know what is this T going to be bound to, what type am I actually returning, I can't figure that out from the inputs. I can only figure it out by knowing what the output type is going to be.
But so you're saying it's at runtime. You can't figure out the type except at runtime.
No, at compile time.
Okay, but you can't figure it out statically when you're writing the code. You can only figure it out.
Correct. You can only figure it out.
You can
by
only
where
figure
it's
out when
called.
that function is used.
Yeah, you can only figure it out by the context, right? And so the point is that you can tell based on what the input arguments are, but you can also, there's also cases where you can only tell based on what the type of the output is, which might not be purely based on what the input types are.
Because why? Because why isn't it only based on the input? It's based
because you can have a definition. You can have two versions of range: one that returns a list vector and one that returns a packed array.
Yeah.
And it's sort of
they're overloading on the output type. Right.
So
it's
why isn't this sort of sliding into dependent types? Or am I wrong?
I don't think this has anything to do with dependent types.
But the type depends on something. The
dependent types is
dynamic.
more about runtime. I mean, in this case,
okay.
it's more just that it's when you compile it, it means it depends on the context of where the function is called, right? Which is already the case in the sense that, if you have a polymorphic function, which is where this applies, then you already need to know the context of what the input types are. And now this is just sort of saying, well, then you also need to know the context of what the output type is. Because the point is, unlike in evaluated code, where you can only overload in the inputs, here you can also overload in the outputs. Because the type inferencer is going to, do it.
Right. So you needed a declaration for the type that is only to be determined, that is to be automatically determined at compile time.
Right. I mean, so this is basically just, you need to somehow be able to ask, hey, what's my return type going to be? Right. And so that's what this.
Ask
you know what the arguments are
in here in the compiled code.
Yeah.
In the compiled code. So for example, you'd say, right.
I see. So it's like in C, you might have a size of, for example, that is a sort of pseudo macro thing applied to types that resolves. I don't even know when size of resolves. Does that make any sense?
I mean, that's
at compile time when the type is known.
Well, I know it's a compile time, but I just don't know what
you could do. There is a size of. You could do size of return type.
That's a different. Well, okay, yeah, sure. I mean, that would be something that.
Or you could do print. You could do print. I don't know. So.
No, but,
right.
what you're saying is that we will have also a size of thing that is resolvable at compile time.
Yeah, we have
yeah,
it.
we already
see
do.
it's like a macro. Okay, what is it?
We've got to have
size of.
Here's an idea for a simple example. So suppose you want to write accumulate as opposed to range, and you could have a packed array which is, real, or a packed array which is complex. And what you want to do is you want to start with something, say, call a variable sum. You want to say sum equals 0. Well, you want that 0 to either be complex or real, and that's where you would use the $return type.
That's a good example, Rob. That's a good example. Yeah. So you would do something like sum equals, typed of 0 of element type of dollar, return type.
Precisely.
Yeah, that would be good.
Dan, our live stream is suggesting $function signature as a.
Well, it's not the signature. It's just the return type.
Yeah.
I'm a little confused by. Unfortunately, we have run out of time here.
Yeah. Well, okay. So the last thing, which is a big one, is sort of talking about compiler-backed packlets, which is related to some of the down-valid compilation stuff, actually. But basically, this is about if you want to write a packlet that well, the two different cases, but I mean, it's if you want to write a packlet that either is a top level thing that relies on compiled code, or you want a packlet that extends, the compiler, then these are the.
There's a third
this is
case
the
actually,
functionality.
Christopher, which is building. There's more cases. There's building a library from compiled code in the packlet, and there's also
Yeah, I mean that's
yeah.
I consider that the first one, but yeah.
Let's continue. We probably should try to get a 2-hour slot if we can, at least an hour and a half, maybe Thursday.
Hour and a half. Let's have frequent shorter meetings are better than infrequent long meetings.
Well, okay, except that it takes me a little while to get my, it's like the compiler.
But
it takes me a little while to get the state.
And then you'll keep warmed up, you see. So
all right. Well, okay, let's try and plan for Thursday.
But fine. Wait, whatever.
Right. Okay. Well, a lot of interesting stuff.
Right.
And I mean, we're just in the middle here, so let's plan to continue this as soon as we can.
Sounds good.
Okay. All right.
Okay.
Thanks a lot.